Okay, so good afternoon, ladies and gentlemen. My name is Piotr Smoczyński. I work as RAMS manager in Rail Baltic Estonia, in a so-called implementing body of Rail Baltica global project. And today I would like to tell you some words about ensuring safety through the use of a European Union regulation called Common Safety Method on Risk Assessment. Before we start, there's one organizational information I would like to share. As with the other Rail Baltica Academy lectures, we are connected via Slido. You can ask me questions, but I would try to answer them only after the lecture finishes at the end of our meeting. As this is a QR code you can scan, and it will help you to navigate through the tool for asking questions. I'll try to answer all the questions, but it will be easier if they are connected with the topic we are covering today. And it will be divided into 3 sections. The first, I call the word of safety word. Sorry for a little pun here. Then what is risk management? It will be a very important tool for ensuring safety. And the third section, a short one with just 3 slides about challenges which we have in relation to risk management inside our Rail Baltica project. So we start with the first thing, with the word safety. And we are here from many parts of the world, possibly, so we use several languages. But I think in all the languages, there's a basic categorization that can be used in order to divide words. The first category are the words which describe things which we can touch, like a locomotive. So according to Oxford Dictionary, a railway engine that pulls a train. Everyone knows how a locomotive looks like. Most of us can go to the nearest railway station and see a locomotive. Perhaps not exactly like this, not a steam one, but an electrical one or a diesel one or hydrogen one. And what is important here, if we see 2 locomotives, we can easily compare them. We can say which one is bigger, for example. And these are the words through which we start using language. And when we teach children how to speak, they will start with, this is mommy, this is daddy, this is a window, and so on. But it's not enough in order to have a proper conversation. We need also a lot of words which are more abstract, like love. We know that love is a very strong feeling of liking and caring for somebody or something, especially a member of your family, of a friend. I think we can love locomotives as well. But this is something much more abstract. We cannot measure love directly. It's always the question, who you love more, daddy or mommy? It's not possible to answer such questions objectively. We see love only through the decisions that people make, but we cannot see it straight away. And I would say that safety, it's definitely the second category word, but it is even more complicated than just love. Very often it's not defined at all. In many books that are talking about safety, the word safety is not defined. But if it is defined, then it is done very often like it is in our railway legislation, like as a freedom from unacceptable risk of harm. Freedom from harm, from risk of harm. So basically, if we want to have more safety, we have to have less risk. They are connected negatively, so to say. So in order to measure safety, we would have to measure risk. And risk is in itself a second category word. We cannot measure risk directly. We can only measure it indirectly in some more sophisticated ways. I know it may look a little bit like a university discussion, but it is actually quite connected to ensuring safety, which I will show you in the later slides at the end of today's lecture. But even right now, we can think for a paradox that the definition of safety creates. If we have a regulator who would like to do everything in order to increase safety on a system which he or she regulates, he can use actually quite a lot of different techniques, different tools. One of it is risk management. But it is impossible to see directly if the safety has really increased after using this tool, because we cannot measure safety. We cannot measure also the risk, which should go down or go up. The only thing we can really measure are accidents, incidents, near misses, things that really has happened in the real world. And it is not a big problem until we have a lot of accidents to measure. But in a safe systems like railways, we don't have these accidents. So we don't have actually a measuring signal which we could use in order to say if our steps, if our actions increase or decrease safety, or they are perhaps not really relevant in terms of the level of safety. Brutally speaking, we don't kill enough people in order to be able to measure safety in railways. And this is a quite known problem in the scientific world. If someone is interested, then definitely the first book to be read about it is one of Professor Eric Holnagel from 2006, Safety 1 and Safety 2. I think it is the first book which has really started the discussion in the scientific world. It's not really scientific in itself. It's quite easy to read and definitely worth recommending. So this is a little bit blurry. Yes, safety is a little bit blurry from the scientific point of view, but it is a driving force for a lot of things what is currently happening in railways in the real world. If we go to a railway undertaking, to railway infrastructure manager, we'll find safety management systems, safety managers, safety analysis, safety measures, technical safety, functional safety, occupational safety, and a lot of other things. And this is because safety is like love. It's a value very important for people, and definitely would like to do something in order to increase this mythic safety. And at the other hand, there's quite a lot of legislation that actually makes us deal with safety in a more sophisticated manner. And in the European Union, the most important is definitely Railway Safety Directive, which is then transposed into the legislation of all the member states. But there are also regulations which are directly usable in all the member states. From our point of view, from the point of view of today's lecture, the most important is the common safety method on risk assessment. But it's not the only one. We have a separate regulation on safety management systems. We have a separate regulation on monitoring and some other related, for example, to supervision done by national safety authorities. So this is one part. The second part are European standards. The most important here being the European standard on so-called RAMS. This abbreviation stands for reliability, availability, maintainability, and safety. So as you can imagine, it's a little bit broader sense than just safety, although they are all interconnected in reality. They are not dealt with separately. And if a project is conducted according to the standard, then by definition, it also agrees with the CSMRA, with the regulation, because they are in line with each other. And apart from this framework line standard, there is also a set of standards regarding particular methods we can use in risk management for identification of hazards mainly, like failure mode and effects analysis, like failure tree analysis, and again, many, many more. As I said, the most important from our point of view will be this common safety method on risk assessment. And if we open it, then we can easily check the scope of the regulation. And as you can see also here, the regulation shall apply to the proposer as defined somewhere else when making any change to the railway system in a member state of the European Union. And the changes may be of a technical, operational, or organizational nature. So basically all the changes are in scope of this regulation. If an organization is dealing with railway stuff, if it is a railway infrastructure manager, railway undertaking, and there is a change that should be introduced by this organization, then definitely this regulation should be used. We'll not go through the whole text of the legal act, of course, but just the few most important things that you can find there. We are dealing with all the changes, and there will be asked a first most important question: if the change that is going to be introduced is related to safety or not. If it is not related to safety, then the regulation ends. Nothing else should be done. But if it is related to safety, then another question comes: is the change significant? And as a default, we use 6 criteria that are also described in the regulation: failure, consequence, novelty, complexity, monitoring, reversibility, and additionality. If after this analysis a change is deemed to be significant, then a full risk management process should be carried out. And this process is controlled, is supervised by so-called assessment body. So a special organization with enough competence that is in state to say if the process has been done in the correct way or not. A little bit too much theory, perhaps. So let's take a short example. The examples, there will be 2 examples. I will give examples that are not really related to Rail Baltica, because they will be related to an infrastructure manager that is actually managing the infrastructure, which we are only building. But I think that in this way, it will be easier to understand the main principle. But at the same time, the principle will be the same also for Rail Baltica. The only change is that the change here in our project is actually the new railway line. We are introducing change into the railway system, meaning that we don't have this infrastructure right now, and in a few years we should have it. There's also so-called change in this respect. Sorry. So the first example, we are infrastructure manager. We've renovated track, and thanks to it, we can increase the speed of passenger trains from 80 kilometers per hour to 100 kilometers per hour. We are taking the regulation, and the first question: is the change related to safety? Of course it is. Well, we are driving faster, so it is more possible that something bad will happen. The consequences will be possibly higher in this way. But is the change significant? This is a question which has no clear answer. It will always be subjective. Therefore, we have to perform this analysis in order to say why we think is the change significant or not. But here, I would say that's possibly not significant. The difference in speed is actually quite small. It won't be noticeable. And unless there are other peculiarities which should be taken into consideration and which we don't know basing on just this one sentence, then I would say that this change is not significant. It means that we don't have to perform this risk management process. We don't have to be checked by ASBO. But if it were significant, then this full risk management process is obligatory. And it is also described in the regulation with such a figure and quite a lot of description to it. But I will do it in a little bit different manner, just to pointing out the most important things, the most important concept which we have in risk management. So we are basically beginning the second section of our lecture right now. What is a risk management? I would say this is a way of thinking about world, which can be divided into some processes that are normally performed one by one for the first time and then repeated constantly throughout the life cycle of a product, of a system. And in the linear form, we start with risk assessment that consists of risk analysis and risk evaluation. And then we have also reaction to risk with risk treatment, risk monitoring, and risk communication. The exact names can differ. We don't have a full agreement on how we call different concepts here. So they can be called differently, but the logic behind the names should be the same in the whole risk management, actually, no matter if it is in railways or somewhere else. The steps, the logic should remain the same. So we start with risk analysis, which means a systematic use of all available information to identify hazards and to estimate the risk. And in order to do it, we have firstly to define our system, to define what we are dealing with. And this is particularly important in case of changes we are introducing, because we have to assume that the system before the change is definitely safe. And there are different ways we can describe the system with diagrams, photos, verbal descriptions, process maps. But there will be also some things which we always have to name, like the elements, the functions, the boundaries, the interfaces, the way how we interact with outside world. And there will also be a place for assumptions. It is always nice to make the assumptions in a clear written form, because it is easier then to check if the assumptions are true, are still true after some time. I'd say that with defining system in terms of risk management is a little bit like with using another language. It can be seen throughout different normal languages like English, Estonian, and Polish, but it can be seen also with languages of a little bit different type. If we are using English, then right now we see a person playing baseball. Perhaps not here, it is not clear, but we could talk about weather, we could talk about if there are any other people or not. But if we use another language, language of maths and physics, then we will start to notice completely different things that are not really possible to capture with just English words. And if we start with describing it as for an exercise in school physics, then we will see forces, we'll see energy, we will see distance that the ball covers after being hit with a particular force. And it is similar with the risk management. If we start to describe a domain with the risk management way of thinking, then, for example, we'll see that there is a potential interface with our neighbor's window. And if we realize that such interface exists, that most probably we'll find another place for playing this game in order not to go through the interface, not to break the window. Very often, it will be enough just to describe the domain, to see which problems we can have inside the domain. But it's not always like that. And the more complicated the system is, the more specific tools are needed in order to really get the full information. And therefore, we need the hazard identification phase. which is basically looking for scenarios, negative scenarios that can happen in our system. Formally, hazard identification means the process of finding, listening, and characterizing hazards. And there will be two main approaches that can be used for it. The first is called forward approach. And this is the situation when we stay inside our domain and we look on different parts of it, of different elements, and we try to anticipate which problems can be caused by these elements. The most typical place when we use it are studies connected with technical objects, where we have the full list of elements that the objects consist of, and we try to find out in which way the elements can break and what does it mean for the whole object. This is basically the idea under failure modes and effects analysis, one of the methods which I showed you as this box, standard box, a few slides before. So we can go forward from elements to potential problems. But we can go also backwards from potential problems to the reasons why this problem happened. And here the most common practice is to use this fault reanalysis technique when we start with top event and we try to find out why this top event could happen, possibly finding out the ways which normally would not be anticipated by us. Perhaps we'll find in this way some mechanisms that can lead to negative consequences, which normally we would not be aware of. Normally, both techniques should be used, and inside these techniques, more methods that are related to the particular type of system which we are analyzing. But it's important to remember about the final result we want to achieve. And the final result from the hazard identification stage should be a list of fears, a list of things which we are afraid about, which can cause harm to us in many different ways. And if such a list is short, we have only 2 fears, then we have to deal with them. And actually, the rest of the risk management is not really needed. But if we have a lot of such fears, then most probably we will not have enough resources in order to deal with all of them. And therefore, we need the next step, the risk estimation. It will mean the procedures used to produce a measure of the level of risks being analyzed, consisting of the following steps: estimation of frequency, consequence analysis, and the integration of those two. With simpler words, we have to determine how much we are afraid of particular hazards. And we'll do it through a risk model, so a recipe for defining our fear, a recipe that will translate different criteria into the final value of our fear of a particular hazard. And after this step, we should have not just a list of fears, not just a list of negative scenarios that can happen, but also this list should be ranked from the one we fear the most to the one we fear the least. How it can be done? No, we use these risk models, such as the one which was developed in 1970s for US military, but is still in use mostly in occupational safety. I use it as an example because it nicely shows the full potential of a risk model. So firstly, it defines 3 different criteria which should be used in order to estimate the risk. We have a possible consequence, exposure, and likelihood. And each of the criteria is defined through a table with different values in it, from 100 to 1 in terms of consequences, and with different values from 10 to 0.5, 0.1 for the exposure and likelihood. And in order to get the final so-called risk score, we have to multiply the values read out from these tables. Let's make a short example. These are the same tables. We have the formula. And as some of you perhaps know, it will probably come at the situation when on some of our stations, we will have a special platform gates, which are normally closed. When a train arrives, they will open. People can get out of the train, come inside the train, and then the gates will close again. And definitely there is a possibility that someone is being trapped at platform gates. So it's between the doors at the time when the doors are closing. We fear it. How much do we fear it? The possible consequence. Well, let's say it will be the first level. Because normally we should have some sensors inside the doors, so nothing really should happen. Perhaps a little bit will hurt a little bit, but nothing more. The exposure is not continuous, but it will be frequent. Many times a day on each of the stations, such platform gates will close. And the likelihood, I would say, quite possible. Perhaps not all the passengers will be trapped, perhaps not all the times, but it is quite possible that the situation will happen. And if we multiply those, we will get 36. So first comment here. Of course, you could choose different numbers. It's not always 36. It's not 36 for every one of us. And this is because of different things. Most important that the descriptions here are quite short. They could be longer, but even if they are longer, there will still be problems because we are trying to grasp a continuous reality into just a few categories, and there will always be some problems with it. And the second thing, I've made an assumption that the sensors in the doors are working correctly. But if it is not the case, then the possible consequences, of course, will be higher. Yeah? Broken arms, broken legs, and so on. So important, perhaps serious. Yeah, we've made an assumption. How relevant this assumption is, how good it is, that is another question. Okay, but let's say we have this risk score 36. Is it good or is it bad? Not all the risk models have it, but quite a lot have also a way of translating the result into some kind of category. And here we have actually 5 different categories with perhaps acceptable risk, possible risk, substantial risk, high risk, and very high risk. We are in the second lowest category here, from 20 to 70. So I think the risk could be accepted, could be deemed acceptable, could be accepted by us. And this scale which we have here does not belong to risk estimation anymore. It belongs to a risk evaluation, which is a procedure based on the risk analysis that should determine whether an acceptable level of risk has been achieved. So here we are assigning the risk of individual hazards to one of categories: acceptable, tolerable, or unacceptable risk. Very often we use also colors here with green, yellow, and red, respectively. And the final result of the risk assessment, we not only know what we fear, we not only have the ranking of the fears, but we also know which should be dealt with. So if they are red, if they are yellow, we definitely have to do something. If they are green, perhaps it's not so relevant. And then also reaction to risk with risk treatment. We can accept the risk if it's green, but if it's yellow or red, then we have to do something else. But there are basically three different ways. The first is risk avoidance. And this is the situation in which we fear something, so we don't do it at all. In Rail Baltica context, we fear about the collisions between trains and cars on level crossings, so we don't have level crossings at all in Rail Baltica. That's a clear risk avoidance. Then we can transfer risk to insurance company or to some subcontractor. Very nice thing, but not always possible. The most often used will be risk reduction. So the situation in which we try to add some safety measures in order to lower the risk, to keep the risk on acceptable level. The two other reaction to risk paths, risk monitoring and communication, are more related to the common safety method on monitoring. That's why just one sentence here. We have to check the fulfillment of assumptions, reviewing the analysis area in terms of new hazards. The process should be living. It should not be only one-time thing. And also risk communication, ensuring that the risk management results are used in real life. Not exactly the part of common safety method on risk assessment, but definitely a part of a risk management as a whole. Okay, and now I have to change a little bit the slides. This should be the next one, our next example. Let's try to use the risk management on something more real than just words. Again, we are an infrastructure manager. Again, we have renovated a track, but this time, after the renovation, the speed was increased 100, but for the passenger train traffic, which was not there before. That's actually a real existing line. I had a real existing line in mind here, but the example can be made more abstract as well. So basically, we have a railway line in which we used to have just cargo traffic, slow trains, not very frequent. And after the renovation, we would like to have the passenger traffic much more frequent with much faster trains. Again, is the change safety related? Of course it is. Is it significant? It is subjective, as usual, but in this particular example, I would say that it should be deemed significant, because it's not a problem to find out quite a list of different things which can go wrong during this renovation and after after the track is renovated and we start this traffic on new conditions. And this list could look like this. Of course, we've made a renovation, but which is the real condition of the track? Is it good enough for passenger trains for this 100 kilometers an hour or not? We are going to have passengers there. So what is the condition of the platforms? Okay, platforms are a part of railway, but it is not enough actually for passengers to use the trains. They have to access the platforms somehow. And the access roads can be often the responsibility of a local government, for example. But we should still check it somehow. It is not perhaps fully railway related, but it is definitely shaping the safety climate here. Are the people aware of the change? I mean here especially the people who are living nearby and who are crossing the tracks illegally outside of the level crossings. They are used to slow trains, so if they even see a train somewhere far away, they know they can manage to go through the tracks. But if the trains go faster, then it's not the case. Yeah? They may not be able to cross the track safely. The same actually is about level crossings, yeah, and car drivers. Do they need an additional information about the fact that the trains go much faster, much more frequently? Perhaps yes, perhaps no. From a different perspective, the railway traffic, of course, has to be managed by someone. It's not like with car traffic, with road traffic, when you just go to your car and you can travel somewhere. Here we have also people working on the other side, on the infrastructure side, on the stations or somewhere in the dispatching center. What about their workload? Shouldn't we get more people there in order to lower the workload? Then we have train drivers. Again, it's not like that a train driver can just go inside a train and drive somewhere. He or she has to firstly get acquainted with the route, and it also takes time. Something completely different, rescue trains. Yeah, we have on our network a few points where the rescue trains are located. And if we start using a part of network which was not used so extensively before, then perhaps it is necessary to move the location of such a rescue train towards the part of the network. Yeah, because in this way, it will be faster for this rescue train to get if something happens there. Okay, the rescue trains are not so often used, but if anything happens, it is quite possible that some local firefighters will go there. Do the firefighters know how a train look like, especially the passenger train? Can they use the emergency exits properly? Perhaps they could use a short training, or we could show them such a train before we really start operation. If there are more trains, then perhaps some extra maintenance is needed compared to the situation from before the modernization. And so on and so on. This list could be extended, but I think I've made the point. And all these questions can be listed as hazards. Not exactly. Hazard has a specific definition, and it's a different story and much longer. Let's assume right now that we can use those questions as hazards, because hazard as a state that can lead to a problem is related to the questions which we have asked here. And then to the risk management, we have identified hazards. We should estimate the risks of the hazards. We have the risk categories here, 2 red, 3 green, and all the rest yellow. And if the risk is green, then we propose some additional safety measures. Additional checks, information newspapers, traffic signs, training course, meetings. And it is important not just to propose those measures, but also to provide evidence that we really have done it. Only then we can be sure that it made sense, that the process is closed. And it's also a good practice to foresee which kind of evidence will really make us sure that the safety measure has been implemented. Contracts, photographs, protocols, and so on. A small print here. The CSM regulation actually does not foresee only the risk models for dealing with risk. We can accept risk also using codes of practice and reference systems. But I think it's a little bit too detailed for today. The logic is similar. Even if we use a code of practice, then this code of practice becomes a safety measure which we have to prove that it is really there, that we have really used it. So the logic will be kept the same. And with the whole package, with hazards, with safety measures, with all the evidences, we can go to our assessment body. And the assessment body will ask a lot of questions, like, is the hazard identification procedure reasonable and used correctly? Have we used the right experts? Have we used the right methods, right tools? Then, is the risk model reasonable and used correctly? Again, it can happen that it is not really correlated with the type of hazards we have. And all the hazards then have green risk, and we are not required to do anything. It shouldn't be like that. Are the safety measures reasonable and used correctly? Are really the additional checks in line with the hazards? It is possible that the safety measures will really change the risk of particular hazard. Then about the evidences, are the evidences reasonable? Are they correctly used? If we say that we need a protocol with some additional checks, mathematical checks, some simulation models, are they really done according to it? Do they have a proper way of reasoning, and so on and so on? There are quite a lot of those questions, and quite a lot of different problems can be seen by ASBO. But I will give you 5 seconds now to think about which question is not on this list. I'm interested if you can think about it. What ASBO does not ask about? They will not ask us, is the change safe? Why? Because it's not possible to measure safety. And that's what we started with. We cannot objectively say if the change increases the level of safety, or perhaps it makes the level of safety, that the level decreases, or it is neutral. We don't know it. We cannot measure it directly. Therefore, we have agreed that we say that the change is safe if all these procedures are done properly. If we had right experts, they used the right tools, right methods, all the evidences are correct, they are really related to the safety measures, to the hazards. If it is like that, then we say that the change should be safe, that it should not negatively change the level of safety in the railway system. Okay, so basically we are using methods, tools that are known in order to prove that what we are doing is safe. So one could think of the challenges. What is a challenge here? What is a problem here? Just take the regulation, take the standards, do what they say there, and you should get through the ASBO, and you should be sure that your change is safe. It's not so easy. Mostly because risk management is more art than science. It looks scientific from time to time because there are numbers, there are some more formal methods, but actually in each step we take decisions that are more of an art than of a science. Just a few examples. Of course we have methods, but which methods we use? We use the FMAA or FTA or any other methods? We have definitely no one method that would allow us to find all the hazards. There's always a mixture of methods needed, and this is subjective, which methods we will use and in which way. Then, which experts should be asked? A topic for another discussion, but it's definitely not the case that the more experts we have, the better the result is. If we have too many experts, they will just, share responsibility. They will stop talking. If there are too less experts, that it can happen that we don't have the necessary expertise. We simply don't know that something can happen. So definitely it is also worth thinking about which experts, how many of them. And it is something that can be challenged. And I think the most complicated one, how probable is that something will happen. It's not so much related to the hazard identification, but if we start dealing with risk, then there's a lot of probabilities. How probable it is that a rail will break? Once a year, once a 10 year, two times a year? It depends. It depends on a lot of things, on the type of rail, on the way how it is mounted, on the traffic, on the technical state of the rolling stock, which we use there. So it is very difficult to say objectively how probable it is that a rail breaks. And even if it breaks, then which consequences does it have? Very often, even with a broken rail, we can still drive our trains. We can just repair it. We can, we have to change the track, this part of track, but it will not mean derailment in all the cases. But on the other hand, it can create a derailment. Should we take the one consequence which is more probable or the one which is worse in terms of consequences? Also very, very difficult. A lot of other stuff, but those things are actually related to risk management no matter where. Not only Rail Baltica, not only railways. All the time those questions will arise. This is just how it looks like. But there's one challenge which is, I think, quite specific to Rail Baltica, which I would like to give you a little bit flair of, but at the same time, I don't want to go too much into details. So I thought how to do it properly. I decided to show you a slide which I've used in one of my internal presentations, which should give you the impression how the Rail Baltica project is divided. So we have Rail Baltica at the top, and it is divided firstly into three subsystems. The infrastructure, meaning the tracks and the buildings, then the control command signaling, which is about traffic management, signals, axle counters, things like that, and the energy, so the catenary and power stations. And this is a division related to interoperability directive, so it is quasi done by the legislation. And the CCS and NA is managed by RB Rail, so by our global organization. The infra part is managed a lot through the implementing bodies. One for Lithuania, one for Latvia, and RBE for Estonia. But again, within the infrastructure, there are slightly differences within the mainline part of infrastructure and the local facilities. Okay, it's not the place to describe these differences, but there are differences regarding to the design of it, for example. And as you can imagine, most of the hazards which we'll have in the future operation of Rail Baltica, they will be painted somewhere across this whole picture here. So different parts of this picture, different actors will have to coordinate themselves in order to be sure that the risk of a particular hazard is on an acceptable level. And if you cannot imagine it, then on the last slide, I would like to point you out some problems which we have on just a normal railway station. How complex it is, bearing in mind that we have different groups of people inside our project dealing with different topics. You can see right now a picture which I've taken on Wrocław Główny. It is one of the biggest, one of the most beautiful stations in Poland. I hope that in a few years we'll have a similar pictures also in the Baltic states, perhaps except of this old rolling stock here. And there are quite a lot of people, and I think that no one of them, including me, have really thought about the complexity of the railway system. But as I said, let's do a short tour. Firstly, we would like to have the train stop next to a platform. In order to do it, the train had to come to the station using electrical power. There's an electrical locomotive at the beginning. So we need catenary in order to do it. The catenary has to be powerful enough to be able to give the energy necessary for a train and so on and so on. So there are problems, there are hazards within the energy system itself that it can fail in different ways. But the catenary will not fly on itself. It has to be mounted, fixed somehow to the structure. So in the infrastructure subsystem, we have to foresee the way how the catenary will be fixed. And as there are quite high voltages there, it cannot be just a fixation point. It has to be insulated properly and also located in a meaningful way. Yeah, we cannot have poles everywhere throughout the platform because the people will won't be able to pass simply through the platform. So two subsystems here. There's also the CCS subsystem, which allows the train to stop on this particular place. Again, it's not road transport, it's railway transport. If the train stops here, it means that it has been foreseen in the traffic management that it can stop here. Sometimes it is easier, sometimes it is more difficult. And definitely the future Tallinn station will be such a more difficult example. For those who can read these schemes, we have turnouts inside the length of the platforms. It means that it is very important to have the signal, the axle counters in the right places in order to be able to really use the platforms, also for two different trains. You can have one train on the left, one train on the right, and this train on the left should be able to go through the turnouts out of the station without touching the train on the right side of this particular track. It is possible to be done, of course, but it will not be done just by itself. Yeah, we have to coordinate ourselves throughout Rail Baltica to really think about such problems, and definitely there are a lot of hazards related to these interfaces. And the last interface, which is possibly the most understandable for the passengers, is the interface between the train and the platform. It is connected with the width of the train and the height of the platform. We have to keep them constant in order to be able to put the train inside the place there. And definitely we have to agree on the values of those values. It's not so tricky, although we also had a little bit problems with it. But more problems are related, and this is again Rail Baltica specific, are related to the way how we will build this part of the railway network. Most probably, and in many cases, it will be built by different contractors. We will have one company which will build some substructure of the track and a concrete part of the platform. Then, perhaps a few years later, we'll have another contractor who will put the tiles on the platform and all the small architecture things and so on. And then at the end, we'll have another contractor who will put the tracks. And I think you can imagine that it is much more difficult than in case of building it all at once. Yeah, we have different contractors, and at the end, the widths and heights have to be exactly as planned in order to not to have too much gap between the platform and the train, for example. We could continue with it, but I think that the lecture is already long enough. That's why I'd like to thank you for your attention. I will look on our questions. So what are some specific challenges that Rail Baltica encounters in implementing the common safety method on risk assessment? I think I've covered it. And these are the problems that we have quite a huge organization inside Rail Baltica with different sub-units dealing with different things. And even if we are one organization, no, there are completely different groups, completely different teams, and these relations between teams can be an issue sometimes. And also the way of constructing it, putting it into several contracts, it also adds some complexity that normally is not so common while using the CSMRA. The second question, can you provide concrete examples of successful risk management practices in the railway industry or in Rail Baltica? It is a bigger question, I would say. I don't know if I can just go with an example straight away. Definitely Rail Baltica is not mature enough to really have such good examples. And with others, I think I would have one, but perhaps in a different occasion, because it would need more explanation, and I don't want to take your time. Does RB Rail and the implementing bodies hold one centralized risk register to mitigate risks collectively? So we have one risk register on the RB Rail level, and then separate registers for all the subsystems, but which are correlated with the main risk register, hazard register from the RB Rail. So there we can trace which hazards in the subsystems relates to which hazards on the system level. And this is quite a common practice that we have these layers in hazard registers, and on each layer we deal with the hazards on a little bit more specific level. Are there any emerging technologies and innovations, artificial intelligence, for example, that have the potential to improve risk management in railways? I don't think I'm a good person to answer this. Definitely, good software can make life easier, but it is more about managing a lot of information. With good databases, with good interfaces to the databases, you don't need a lot of time, so much time in order to trace the hazards, in order to be sure that all the safety measures are there. But this is not really artificial intelligence. What about the AE? I don't know. Perhaps yes, but I don't know. And the last question, how is the platform offset distance accounted for during the normal platform zone and turnout zone? Is it uniform? Again, I'm not the right person to ask for the final decision which has been taken. I know that it was an issue that we were actually investigating it, trying to find out if we can use the distances on the borders and have the offset the same throughout the platform. But I don't want to provide the wrong information. So I'm sorry, but I will not answer this. Okay, I think that these are all the questions. So thank you once again for your attention. I think we can finish.